Hey, 7th grade scientists, coming to you from the Hammond household today. So I actually asked my two kids to help us out today with our labs. So I got Liana over here and I got Braden over here. You guys should know Braden, 7th grader. So we're going to talk a little bit about energy. So last week I told you about how coal becomes electricity, right? There was a whole bunch of things that we had to do to it in order to create light. Because I can't just take a piece of coal and put it next to a light bulb and expect it to create what I want. So what we do instead is we change the energy from one form to another. So in our first quarter, we actually talked about this law, and the law is called the law of conservation of energy. And that law states that energy can't be created and it can't be destroyed, it can only be changed. Now that of course only applies to planet Earth because we talked about stars being able to create their own energy, right? So on planet Earth, the law of conservation of energy applies, right? So we are not destroying any energy and we're not creating any new energy, we're simply changing it from one form to another so that we can take that piece of coal and make the electricity in the light bulb light up, okay? So we're going to talk a little bit about the different kinds of energy and how they would flow into each other. So the best example that I can give is when we made our roller coasters at the beginning of the year. Do you remember doing that? Okay, so when we did our roller coasters, we took a piece of track, right? We had a marble, and we started with potential energy at the top of the hill, right? So it's sitting up there, and then we released the marble, and when the marble was released, then we created kinetic energy or movement energy, and that energy moves all the way around. We changed it from potential to kinetic to potential, and eventually, and when we got to the end, we wanted to stop it. We used what kind of energy?
Friction or thermal energy.
Okay, thermal energy. So sorry, we have a train passing by. It's part of the deal over here. So we have thermal energy. So if I put that into a flow chart, I would talk about the roller coaster starting with potential energy, like this, right? And then going into kinetic energy, and then eventually into thermal energy, right? So that would be the energy flow chart. So I'm going to remind you a little bit of the different kinds of energies that we're going to be talking about today. So then that way, as you're watching and seeing the different labs, you can figure out which energies would happen at what time. So the first one is light energy, and that one's pretty self-explanatory. That particular energy comes from
The
light
sun.
source.
Light bulb, sun.
Right, any kind of light source. All right, then this one is sound energy, and it's energy that travels in waves that creates sound. So can you give me some examples?
It's loss of energy. So, for example, if I use kinetic energy to move the table, then part of that energy will be lost through sound.
Okay.
And then talking and eating food is also sound energy because you're making sound with mouthing.
Okay, and even behind us, we have a train that's moving past. You guys can see it in the window, right? That train not only is having kinetic energy, but part of that energy is being released into the sound going into the...
It's kind of like friction, how it's a loss of energy going on the tracks. You lose a lot of that energy through friction. You also lose some of it through sound.
Right.
Yeah.
Okay, so then moving to chemical energy. Chemical energy, we're going to talk mostly about in the form of batteries. So batteries have acid and different chemicals inside of them. When we want to use that energy, we force those two chemicals to mix together, which then creates a reaction, and that reaction then gives us whatever we want the battery to do, right? Light something up, or turn your Xbox on, or whatever it is.
Usually it gets turned into electrical energy.
Okay. All right, so then our next one is kinetic energy. And what does kinetic energy mean?
So kinetic energy means like something in motion. So me moving my hand is kinetic energy.
As I mentioned earlier, me moving my hand into the desk and punching the desk, that's kinetic energy. I'm using my kinetic energy to hit the desk, and then the desk is absorbing that kinetic energy and moving.
Okay. Electrical energy. So electrical energy in this particular scenario is talking about energy that comes from electricity. So when I'm looking at something being plugged into the wall, like your charger for your cell phone or your TV, we're going to talk about the wires, right, coming from the wall into whatever the thing is as being electrical energy.
Yep.
Okay. Potential energy.
It's
pretty much
the
energy
potential
has
to
potential.
move. So if something's up here and it has the potential to drop with kinetic energy, but it is not yet dropping.
Okay. But if I have it on the table, there is no potential energy, right?
You cannot just go through the table.
Okay. All right. So then the next one is mechanical energy, and that's an energy from a machine. So whether that's a very simple machine like a top, which you're going to see in a minute, or whether that's
Like
a
a
more
motor.
complicated machine
Like motors.
in your car, right?
Yeah.
Or a turbine that's turning to create electricity.
Yeah.
And the last one is thermal energy.
Which is heat energy, friction.
Okay, so that could happen in friction, and it could
Fire.
also happen when we're trying to burn something. You're going to get heat energy.
As I mentioned, it shows up a lot as a loss of energy when we're talking about like cars or trains or movement.
Okay?
Yeah.
And part of thermal energy also comes from the sun, right? That's one of the things that it gives us. It gives us radiation, which then is in the form of heat.
Yeah.
So I have two examples of energy, and you're going to see how these flow so that you can see how we will do the labs moving forward. So Liana here has a top, and the top has a string attached to it, and that string is full of what kind of energy?
Potential.
So if I pull on the string using kinetic energy, then I'm going to get what?
More kinetic energy.
So, but it's in a machine, right? Simple
Mhm.
machine,
So
right?
it's
So-
a mechanical
So it goes from potential energy in the string to kinetic energy in your arm to mechanical energy here in that piece of wood. And that's the energy flow chart.
And then more potential energy coming out.
All right, so Braden, you have a flashlight.
And it is filled with batteries, right? And as we talked, the chemical reactions inside these batteries cause the energy. So when I plug in the batteries and twist on the top,
So we start with chemical energy as the flow chart, and then it goes into
it will go into electrical energy, and then light energy.
so chemical,
Turning it on.
electrical, light energy.
I put the battery in backwards, but you get the point.
So chemical, electrical on the wires here, and then light coming out this side.
Yep.
Okay, so we're going to use that information, and we're going to take these cards with us, and I'm going to show you 5 different labs. I'm going to read the directions, and my kids are going to do the actual experiment, and then they're going to tell us what the energy flow chart is going to look like. Okay? All right, so let's move over to lab number 1. All right, so lab number 1 is over here, and here's the cards. Here's the cards. Okay. So lab number 1 says to rub your hands together, gradually picking up speed. Okay, so if you run your hands faster or slower, what's going to happen, Liana?
So when you're starting, it's potential energy,
Uh-huh.
and then it goes into kinetic energy because you're moving your hands
Okay.
at speed, and then it goes into thermal energy because it's friction, so it's heating it.
Okay, so point to each card. You got
So it
potential.
goes potential,
Okay.
kinetic,
Yep.
and thermal.
Great. So that's lab number 1, potential, kinetic, thermal. Okay, moving to lab number 2. Slide on down. Lab number 2 says, turn the generator to LED and crank the handle to light up the LED light bulbs. Okay, perfect. All right, this one's a little bit more complicated,
A
right?
little bit, yeah.
So, Braden, can you walk us through what's going to happen there?
So we have kinetic energy, which is Leona's hand turning the crank,
Okay?
and then we have mechanical energy of the gears in here moving, and then that turns into electrical energy.
Okay.
And then that energy gets turned into light energy.
So, putting them all together, you have
You have kinetic, then mechanical, then electrical, then light from the LEDs.
okay, perfect. So, kinetic, mechanical, electrical, light energy.
Light.
Okay.
Great. So Braden's going to go outside because this next part actually has to do with the solar panel. All right, so this one says expose the solar panel to the light until water comes up out of the bowl here. And if you're looking, you see right next to Liana, we have a bunch of water coming out now.
Like a little fountain.
Okay.
And so,
All right, that's good, Brayden. Thank you.
so it starts off with light energy,
Okay.
and then it goes into electrical
Wires.
energy,
Good.
and then it goes into, if I can find it, mechanical energy.
Okay, so hold those up.
So it goes from light
Okay.
to electrical to go through the wires to mechanical for the water to pump up.
Yep, there's little like motors making the water pump up.
Okay, great. So we're gonna move over to lab number 4 here. Okay, lab number 4 says, turn on the wax warmer. Okay, and you're gonna watch it for just a minute. All right, Brayden, if you watch this long enough, what would happen to the wax?
It will get melted from the thermal energy.
Okay, so what's the purpose of the light inside of the wax warmer? You can pick it up and show them.
Yeah. Well, the wires plug into a wall outlet, which comes from electrical energy.
Mm-hmm.
And then it goes into a light bulb, which emits light energy, and it then hits the top dish, and there's losses through heat, which we're using those in order to heat up the top dish and then melt the wax and make it smell nice and pretty in here.
Okay, so the difference this time with the light bulb is we don't actually care about the amount of light coming out of the
Yep.
light bulb. We
It's
care
the
about the
heat.
heat from the
Yep.
light bulb. So the energy flow chart in this case is going to be,
Electrical, if I can find it. Where is it? Dang. Electrical,
okay,
then into light,
okay,
and then that goes into sound. No, I'm just kidding. That goes into thermal.
okay, so it goes electrical, light, thermal energy. Great. Okay, here's our last one.
Just us.
Okay. Last lab says for your partner to stand up and to put the ball near their waist.
I'm just gonna do it over the table.
Okay, and then they're going to drop it and see how many times it bounces. Okay, so 8 times. So have a seat.
Okay, so that one has potential energy when you're holding it up, because it could bounce up and down. And then it has kinetic energy because it's bouncing up, down, which is moving. And it goes like that until the ball stops, and
So it's potential up here, and then
kinetic,
and then when it goes back
potential,
up here, it's potential, kinetic.
potential, until the ball stops.
Leapfrogging between the two of them until it loses all.
So it keeps going.
Awesome. So finishing up our lesson today. If I was to ask you then to tell me a energy flow chart with a campfire, could you show me the energy flow chart in that case, very simply?
The log, like it has potential energy because it's it could burn up.
It's potential, right?
And then,
And then
we put a chemical, we make a chemical change, which is the fire, going onto the log, which then
Okay.
lights it up and causes
thermal.
thermal.
So we would go potential energy, chemical energy, light energy, heat energy.
And then the light and heat are both combined together because it lights up the night when you're out camping, and it also emits heat to keep you warm.
Yeah.
Great. So that's how energy flow charts work. I'm going to be asking you some questions about energy flow chart in your Google quiz. I hope you guys are all happy and healthy and safe, and I miss you guys. And I hope that you guys are having a great day. So we will talk to you next week.
Bye.
Bye.